Nice. Itu great ya. My mom is right now looking. It's like just kind of inefficient.
Welcome back. So today we're going to be doing another demo, continuing with what we were doing last time. So on Monday, you should have downloaded the demo code and set up your virtual environment, but I know some of us weren't here, so I'll give you a few minutes to do that now. You go to our course syllabus inside of our first chapter routes under pre-class to-dos. You should see the zip file for the demo code. Go ahead and open that. Okay, so if you guys remember from Monday, we talked about the client server model. Basically, the client is the computer, like our phone or our laptop, that interacts with the front end of our app, and it sends requests to the back end. The back end processes those requests and then sends the data back to the front end. So today we're going to work on development locally on our computer. So in our case, both the client and the server are going to be our laptop. But in the real world, the client might be an app on your phone, and the server could be some remote server anywhere else in the world that you're connecting to. So for example, when you open Google on your computer acts as the client, and it connects to any one of Google's servers it has around the world, one of which is going to handle your request. But for this demo, our laptop is going to play both roles. So let's navigate to our code from last time. I'm going to open up a new terminal, and I'm in my home directory, and I want to change a directory into where my code is located. So for that, I'm going to do change directory, desktop, backend course. Okay. If I type ls, I should see all of our files from last time. And now I'm going to use the shortcut we set up yesterday to open up the current directory in Visual Studio Code. Okay, so now we see our code from last time. We have our requirements.txt, our app.py with the minimal code we have set up.
It's a lot of delay.
Oh, yeah. I was with there. See what this one goes. Okay.
Is that better or worse?
Right on, like turn off those from this. Is that better?
Yeah.
Okay, that's
Where the file is at.
Okay, so we have our code from last time, our requirements.txt, our app.py, and our virtual environment. So the first thing I'm going to do is activate my virtual environment. On Mac, that's going to be .ven bin, which stands for binary, and then activate. On Windows, I think that's going to be then script activate.ps1. So now that our virtual environment is running, I can use Python to run this file. The way that we do that is by running python3 app.py. And you hit enter, and you should see some output in your terminal. It's telling me that my file is running on port 8000, which is this port right here. So as Daniel mentioned on Monday, a URL is made up of several different parts. The first is the domain name, like google.com, which connects to the server hosting the website. When we're running on our computer, the domain is localhost, which means we're connecting to a server on our machine. After the domain name comes the route, and the route is the part of the URL that tells the server what specific data or action we're requesting. So in this case, our server is running on localhost port 8000, and the route we're trying to access is this one right here, the slash. So I'm going to navigate to that page. Localhost port 8000 slash. We see our hello world text. I'm just going to close. So now that I have my server running, we can get into the syntax of how we actually create routes. So in our Flask application, we define routes using the app.route decorator. And the string inside the decorator is the name of the route. So for example, if I changed our route name from slash to backend, if I come over here, I'm going to get a URL not found error. And if I navigate to backend, I see that our hello text again, because our route is now located under the slash backend name. Then directly beneath our app.route decorator, we define the function that we execute when our route is called. So right now, we just have this function hello, and we're just returning the text hello world. But if I change that to say hello, and I reload the page, I see that we're displaying hello. Does that syntax make sense? Okay, cool. So now we're going to start creating a backend that's going to actually be functional for us. And to do that, we have to import a few libraries. So the first library we need to import is JSON. So we can type import JSON at the top of our file. But this is going to allow us to interact with JSON type data. And that's the type of data that we use to send and receive data from front end. And then the next thing is from Flask, we need to import a package called requests. If you remember from Monday's lecture, the client sends a request to the server, and the server sends a response back to the client. So the request package allows us to access the data that's being sent from the client. So we can write from Flask import request. Okay. So now that we've installed our libraries, we can go ahead and start creating our first route. So for this first demo, we're going to be creating a backend for a to-do app. Our to-do app is going to store a list of tasks. The tasks in our app will each have a description and a status indicating whether they're completed. And for this simple demonstration, we're going to represent our data using Python dictionaries, which are similar to Java's hash map for those of you who are more familiar with Java. The syntax to create an empty Python dictionary looks like this. And then inside our dictionary, each task is going to be represented by a key value pair. So the key is going to be a unique integer, which we'll use to identify each task separately. And then the value is going to be the actual dictionary object we're using to represent the task. So each task is going to have a few fields. The first field is going to be the ID. Then we can have a description, which is going to be anything I want it to be. So it can be something like do laundry. And then we're going to have a done value, which I'm going to set to false because I haven't completed the task yet. Now we can define maybe a second task within ID 1, description of do the dishes, and a done value of false. So each time we create a new task, we're assigning the task ID to the next unused integer. And to make that easier for us, we can add a task ID counter. So this counter will increment when we add a new task. And in this case, the next available integer is 2. So I'll initialize task ID counter to be 2.
Can you like zoom in?
Oh, yeah. Is
Yeah, it's like possible to see.
that better?
Yeah.
Okay. So now let's establish our first endpoint to get all the tasks we've created for our to-do app. Remember that in Flask, we define an endpoint using the app.route decorator followed by the path name. So for fetching all tasks, we can create an app.route decorator with a path name of tasks. Make sure to include the backslash. Yeah, so we preface all of our endpoints with this slash here. That is what separates our base URL from our endpoint. If we didn't have that slash there, for this backend route, for example, that would be the equivalent of just going to like localhost 8000 backend. And we don't want to do that. So we always include a slash before our route name, and we also have a trailing slash. Okay, so now we can define the function that we want to be executed when we hit the tasks endpoint, and we can call that getTasks. So we're first going to create a response object, and that's going to contain a list of all of our task values. And we're just going to return that as a JSON, and we use json.dumps, which is just a function from our JSON library that's going to convert Python objects into JSON formatted strings. And we're going to return that with a status code of 200. Which is going to represent that our data was retrieved successfully. Now if I go ahead and hit this endpoint, I see that we have a JSON list of all of our tasks being returned to us. Okay, now we have a route to get all of our tasks, and we can create a route to add new tasks as well. But before we do that, let's get Postman set up. And Postman is the tool that we're going to be using to create all of our API endpoints. So if you haven't already, you can go ahead and download and install Postman. We have the link to it in our pre-class tasks. And once you have it installed, you can open it up. I'll give you a moment to get that open. Okay, does everyone have Postman open? Like 30 more seconds. Okay, so once we have Postman, we're gonna create a new workspace. It's just gonna be a blank workspace, and we're gonna give it a name of Backend course, spring 24. And you can set that to a personal workspace. This is where we're gonna like put all of our routes for the course.
Okay.
Full 24? Or,
Yeah, all 24.
Yeah, just you can name it file 24. The name doesn't really matter.
Yeah. And then inside this workspace, we're going to create a new collection. Let's name that Demo 1. And inside of that folder, we are going to put all of our requests for this demo. So now let's create a request to test our tasks route. I'm going to go over to these 3 dots and add a request, which I can call getAllTasks. And then now we want to set our URL to match the one we defined for our route. So for us, that's going to be localhost 8000 tasks. And when I hit enter, I see a JSON formatted all of our task objects. If you have the body like response format set to HTML, it might look like this. So to make it like more readable, we set it to JSON. Okay, so now that we have Postman set up, we can go ahead and define a route for our new tasks. So right now we only have 2 tasks, and if we want to add a new task, we have no way of doing that without rerunning the server and updating our tasks variable. So let's create a route that allows the client to send us data that we can use to populate our database with a new task. So I'm going to create a new request. We can keep the same path name, but I'm going to change the HTTP method to post. So if you remember from lecture on Monday, the HTTP method specifies what kind of request you're making to the server. A GET request, which is what we have here, and what we use by default, tells the server that we want to retrieve data, and a POST request tells the server we want to manipulate data. So that's what we want to specify for our createTasks method. Now I can create a new function, createTask, and you can parse the incoming data from the POST request using this line, body equals request.json, body equals json.loads request.data. Then so this is how we access data from the request when a client sends something to our API. So for example, when someone sends a request to create a new task, the task data gets sent along with it. So by using JSON, we can grab all that data and convert it into a Python dictionary. And once we have that dictionary, we can easily extract any of the task data we need. So from this body, I'm gonna extract the task description. So we can just say description. Description. And then I can create a new task object using that description. So we can set it to have an ID, a task ID counter, description, and we can set the done value to false because the task hasn't been completed yet. Then we can update, we can add tasks, the task ID counter. And update the task ID counter by 1. And then we can return a JSON of the task and a response code of 201 indicating that our task was created successfully. And then the last thing we need to do is, in order to reference the variable task ID counter, we have to specify global task ID counter at the top of our function.
Can you explain the difference between the response code of 200 and 201?
Yeah, so a response code of 200 is just going to tell us that we've successfully retrieved data. 201 says that we've successfully created or updated or manipulated data. So
Yeah.
What's the difference between lines 29 and 30 and what they do?
yeah, so 29 is where we add the new task we just created into our tasks dictionary up here. And this one updates the task ID counter by 1. So basically next time we create a task, it's going to have like the next integer value set as our ID. So in Postman, now we can test this route. And create a new request, and we're going to set this to be a post request. And we hit enter. We're going to get an error. That's because if I try to send this request right now, basically Postman is expecting some information to be passed along with the request that I didn't provide. So let's provide that information. Do that, we're going to add to our request body a sample task. I'm going to give it a description of do homework. And now if I send that request, sorry, make sure to set the request body as a JSON. Now we have returned to us the task that we just created. We see an ID of 2, a description of due homework, and a done value of false. Now we have routes to create a task and to get all tasks.
What changes did you just make?
Well, yeah, so that's a pretty good example of what can always happen. So we just had some small bugs. So the JSON.loads, that was a typo. We had the A before the O, and so that threw an error. And then the other error was just that our ID, when you see the task in line, what is that? In line 28, we didn't put our ID in quotes. So that's another common error that you can mistake. So that's another mistake you can make. And so you have to make sure that all your things before your values are in quotes. So like the ID, description, and whether it's done, those have to be in quotes. This wasn't, and I was like, so it drew an error.
Okay, so we have routes to get all of our tasks and to create a new task. But what if we want to access just one particular task? So to do that, we'll implement an endpoint that retrieves the task based on the unique ID. And this requires setting up a dynamic URL that can capture an integer value from a path. So to do that, we're going to start by defining a new route. And we can keep the same tasks path name, but at the end, we're going to add a variable part in task ID. And anything passed into this section of the route will be automatically converted into an integer. So now I can pass that integer task ID into my function. So if I create a function getTask, I can pass in task ID as a parameter into that function. So in this function, we're going to attempt to get the task associated with the ID passed in by the client. So you can say task equal task.get task ID. If we can't find that task, we're going to return an error to the client, telling them that our task wasn't found and giving them a status code of 404, which indicates that the requested resource was not found on the server. If the task does exist, then we're going to return the task as a JSON object along with the status code of 200, which signifies a successful operation. One thing to note is that since our,
Why do we return a JSON dumps versus just returning the string task not found?
yeah, so the JSON dumps is what's gonna turn like our task into like a JSON, which is the format that we use to send requests and responses.
Line 35, should it be tasks.get instead of task?
Oh, yes, you're right. Yeah. Yeah, since our tasks are stored in a Python dictionary, every time we restart our Python script or our server, the data is going to get erased. This is why in production, we use databases, which will store data permanently, which is what we call persistent memory. Now we can test our new route using Postman. So we can open Postman and add a new request. And then from our tasks, I can just choose one that I want to return. So let's choose this one with an ID of 1. And if the task ID exists, you'll see the details of the task. If not, you're going to receive an error message and a 404 status code. So if I were to try and get task with an ID of 9, for example, I would get an error saying that my task is not found. Let's say that we finish a task and we want to set its done value to true. We can use a dynamic URL that includes a task ID similar to retrieving the task, but this time we'll use a post method to update the data. In our update task function, we're going to take in the task ID as a parameter. We're going to try to get the task if it exists from our tasks array. And then it's going to be pretty similar to our previous function where if the task is none, we're going to return an error. If the task is found, the function is going to try to update its fields. So we can try and update the task description. Description. We can get from loading the request data as an object called body. Task description, body description. And then we can also update the done field. And we can return the updated task to the client. So to verify that our route is working, add a new request. Will be a post request. And we can try and update the task with an ID of 1. And in our body, we'll pass in a description. Do laundry and a done value of true. So now we get returned back to us an ID of 1, description, do laundry, and done is true. And if I hit the getOneTask endpoint, I can see that our task has been updated successfully. Okay, so now maybe you finish your task, you set its value to true, and you want to delete it from your server. So let's implement an endpoint that allows users to delete a specific task. So this is going to require us, again, to have a dynamic URL to access a specific task ID. So this is going to be almost identical to our update route. We're going to use a method of delete instead, which is just going to be like specifically for deleting objects. We can rename our function from updateTask to deleteTask. And then instead of grabbing the response body and updating our task fields, we can instead just write deleteTasks task ID. which is going to delete the value with the key of task ID from our tasks array. Now we just return that completed, that deleted task along with a 200 response code, which signifies a successful operation. Okay, now let's make sure that our delete functionality is working as expected. So let's open Postman and add a request. Localhost 8000 tasks 1, and we'll set it as a delete request. Now, if I send that, I get back the task that was deleted. And if I go back into our get all routes, I can see that the task I just deleted is no longer there. So those routes make sense to everyone?
For the get task route, why don't you need to put methods equals get?
So for this one, we're just retrieving all of our tasks. So we're using a get route here, and that's what we use by default. So if you're just doing like a get request, you don't have to specify that.
Okay.
Okay, the final thing I want to cover is just documentation. Documentation is super important, and yeah.
Could you go to the delete task for a second?
Yeah.
Thank you.
There's also a real quick note, obviously take pictures if you want to, but this is also being recorded and will be posted on the YouTube channel, so you can also refer there if like you don't have time to take a picture or you miss it for some reason.
Thank you.
Yeah.
So we require documentation for any assignments that you guys submit. So in Python, documentation within code is implemented using doc strings, which are multi-line strings that we put immediately under the definition of our methods. So for our getTasks route, you might write something like returns all tasks. And in our createTask route, you might write something like creates a new task. And you probably get it for the rest of them. And then just to quickly show you, you're going to need to export your Postman collections along with any of the code from your assignments. And that's just to demonstrate your ability to test your code. We'll do that. I'm gonna hit these three dots here and click export. Make sure that it's version 2.1 and hit export. Now your collection was exported successfully, and you're going to attach that exported file to your assignment submission as per the instructions on the assignment. So yeah, that's everything we have for demo today. Thank you so much for coming. We'll see you next week.
Real quick before you guys leave, there is a Kahoot for attendance, so we're gonna do that now, but the demo portion is over. Quick record.